Hello, Year 12 Extension 1. We're now going to have a look at another, sort of application of the binomial theorem or the coefficients of Pascal's triangle. And keeping in mind that these are the really more common HSC type questions, along with questions on finding the greatest term or finding a particular term. So it's very important that you have a good understanding of how to, master this particular concept. So exercise 5F looks at identities. Now, you've seen identities before. So identity is a given statement, right-hand side equal to left-hand side, and you're asked to show or prove that. So in the identities now, we need to be aware that obviously they're going to have some reference to a binomial and the binomial expansion. And many of the identities will focus either on the coefficients, and it'll be simply a statement involving coefficients. As you can see here, that our left-hand side is a statement about coefficients, and our right-hand side is a variation of a binomial to a power. Now, it doesn't look like a binomial, and you'll see that this number 2 has been created using a strategic substitution, which leads me to introduce the different methods by which we are going to show or prove these identities. There are 3. One is substitution, and you've actually had a brief introduction to proving and showing by substitution when we previously proved a feature of Pascal's triangle. Another method is by calculus, which we haven't done so far. So we'll be differentiating and integrating. And method 3 is equating the coefficients, which again you have seen when we were proving, I think, that a coefficient is the sum of coefficients from the previous line before in Pascal's triangle. So you might be wondering about these identities. These identities come from some variation of the coefficients of a binomial expansion, which in turn relate to the entries, the terms are in a row in Pascal's triangle. And there's an infinite number of patterns associated with Pascal's triangle. And it all depends on maybe some simple combination of simply the elements of a row of Pascal's triangle, or elements of a row might be all multiplied by a constant or divided by a constant. One row might be added to another row, and the result is forms another identity. Like I said, there's an endless, or as it's written here, there's an endless number of patterns. We won't necessarily recognise the identity or the pattern However, once we've shown it, we could always go back to Pascal's triangle and just check that it is working on a particular row. And the textbook does that frequently. So it introduces this identity to you, and then for the first few questions, they step you nicely through the process to show the identity is true. And then they actually suggest that you might want to go back to Pascal's triangle and show that that identity works, for example, when n is 3 or 4, etc. So we're going to focus now just on the first method, the method of substitution, to show that an identity is true. Now, like I said before, the identities are always given, so you don't have to know the identity. However, some of these you will recognise. Some of them are features of Pascal's triangle that we have learnt. And if we're using the method of substitution to show or prove the identity is true, then there's some probably telling features that will help you, one, to know to use substitution, and two, to know what the substitution might have to be. Now, I'll just divert for a moment because there are 3 different methods. I really would suggest that as you do each question, as you're presented with an identity, that you have beside you, say, a single sheet of paper where you're going to have it organised into, say, 2 columns, a smaller column and a larger column, and at least 3 rows. So your column heading is going to be method and example. So this is one whole sheet of paper. And method, so then your second row here is going to be substitution. And every time you do a question and the identity you're showing and proving is done by a substitution method, I strongly suggest you write the identity down here in this space. The next one you do is also an identity that you have shown or proven by substitution, write it in here. So you're going to build yourself a bank of examples of identities, all listed here, which are shown or proved by this substitution method. Your next one is going to be calculus. And again, as you do a question, as you show or prove an identity using calculus, either differentiating or integrating, when you've finished, simply write what the identity actually was in this space. And then thirdly, equating the coefficients, I strongly suggest you do the same. So you'll have many examples of identities, nicely separated, characterized into the groups of equating coefficients, calculus, or substitution. So I strongly suggest you've got that page going. and have it beside you so you can complete it as you complete a question. Okay. Maybe no, I will stop the video now and start another one just in case I run out of time.